Okay, we're back talking about function notation and vocabulary. And we were just talking about relations and whether or not a function is a relation. And let me give you something graphically to talk about that as well. And we call it the vertical line test. And that is used to determine whether a relation is a function. So consider these three examples. The first one, I have drawn just a general parabola on a Cartesian coordinate system. The general form here is y equals a times the quantity x minus h squared plus k. And what I want to know is y a function of x? Question mark. Okay. So what that means is y is my output. It's my evaluation of the function. X is my input variable. And if I'm asking whether or not it's a function, what I'm really asking is, for every one input, is there exactly one output? So let's just take a look. If I have, I'm just going to pick a value, an input here, some x value, does that correspond to exactly one y value? And yes, it does. Now it turns out I could pick one over here, okay, and this one input corresponds, I tried to line this up, to exactly the same output. However, still, if I choose one input, do I get one output? Yes. So indeed, this one is a function. Okay. So I've answered that question there. Although I didn't state what the vertical line test was, which was what I wanted to do. Here's the vertical line test. If I run a vertical line through whatever picture I have on my graph, like this, okay, how many points does it cross? If it only crosses one point, then it passes the test and it is a function. If I try the vertical line test and it passes more than one point, then it does not pass the function and it is not a function. It does not pass the test and it is not a function. Okay, so for example, on the next one, this was what we used previously. Remember, we had a relation that matched even the number, the phrase even, or excuse me, the word even with the number that matches up with it, and the word odd with all the numbers that match up with that. And let's just put this on an XY graph. My even and odd are my inputs, and generically we're saying that x are the inputs, so that's why I wrote that here. And the vertical line test quite simply says, if I choose an input and draw a vertical line, or we'll do the pink through the green here. If I did a vertical line, okay, straight through, how many places does it cross? Well, in this case, it crosses 4, and actually it's an infinite number, right? It's not just a single point, so right away, even with just this, I can say the function is not, or excuse me, the relation is not a function. So here's my vertical line test here also. Nope, it fails there. Fails on both accounts here. So what that means is this relation is not a function. Relation is not a function. That is, y does not equal f of x. How about on the next one? This is generically, it looks like the form y equals 1 over x. I've shifted the graph over a little bit by a, so y equals 1 over x minus a describes what you see in green here. And I'm just going to ask the same question, is y equal to f of x? And this one is kind of interesting because if I do any kind of vertical line test, certainly it passes. I can say, oh yeah, there's only one point that crosses. I could do that over here, yep. That means that for this input, there is exactly one output, and you can see that that's true everywhere. But we do have something interesting. We have an asymptote right here, exactly at x equals a. So technically, yes, y does equal f of x because wherever the function is defined, it passes the vertical line test. The thing is, right here at a, the function is not defined because if you put x equals a right here, a minus a is 0, 1 over 0 is undefined, so it simply means we have to restrict our domain. And so that's what I'm going to talk about in the next video, domain and range. Sometimes, yes, indeed, it is a function, but because of the type of function, the domain is restricted. Okay, so stay tuned for that.